Okay, let's wait for like a couple of minutes and start at 9:35.
Yes.
Okay, Athar, let's start. Like people can join in between as well.
Yes.
Okay, welcome everyone. So this is Research Jam 7th, and so Ayush is engaged in a meet, so I would be taking forward for this one. So today we would be discussing the illusion of thinking, which is Apple's paper. Yeah, you can move forward. Uh, just a bit about Genloop. So we build domain intelligence seamlessly and achieve unmatched cost, control, and performance. So we do it by three simple steps: by integrating with your enterprise data, and then performing all the essential steps in an LLM dev cycle, and then integrating with your application, desired application, in a one-line code change. Yeah. Um, yes. So a good point about LLM Research Hub. So it has all the top curated papers which are ranked by relevance, quality, popularity, and impact. So you can head towards after the meet at genloop.ai/research hub. So you can also be updated with all the top research happening in the industry. Yeah. So yeah, Research Jam is a closed knit community session that we weekly conduct, and it usually has the top research of the research hub, as the illusion of thinking was for the top research of the first week of June. So feel free to share this community session with all the like-minded folks, and yeah, so Atha would be taking it forward. Yeah.
Hello.
Hello.
Am I audible?
Yeah, you're perfectly audible.
Okay. Thank you. So hi guys, I am Atharo. I will be speaking about the paper Illusion of Thinking, like understanding the strength and limitation of reasoning model via lens of problem complexity. This the paper by Apple researchers. Basically, the whole paper focuses on explores the current benchmarking, mainly focuses on mathematical and coding problems, but that problems don't fully capture the true reasoning ability of LRMs, that is large reasoning models. It also highlights the problem that is as complexity increases within the problems, model struggles to scale their reasoning effectively. So now heading towards the slide, like what are LRMs? LRMs are basically, we can say, extended or version of LLMs with a feature of reasoning embedded within them. So some of the examples of current LRMs are like OpenAI's O1, O3 model, DeepSeek R1 model, Claude 3.7 Sonnet, Thinking, and Gemini Flash Thinking, and many more. So basically, large reasoning model demonstrate their thinking capabilities through thinking tokens uh, through the process of chain of thought mechanism. So what the mechanism basically results in various, which yields promising results in various benchmarking. So for this paper, Apple basically uses four state-of-the-art LRMs: Claude 3.7 Sonnet, DeepSeek R1, O3 Mini with its medium and higher variant, and DeepSeek R1 Quen 32 billion. Below I attached the paper link, so you can go through it. Now coming to the next slide. So the paper mainly focuses on LRMs issues which are present in LRM benchmarking. So what they said that like mainly the LRM benchmarking is currently evaluating primarily utilizing existing mathematical and coding benchmarking. While these benchmarks are valuable, they frequently suffer from data contamination, which actually these problems are present in the training data set while training these LRMs. So this is called data contamination. And also this evaluation does not provide any insight regarding the structure and quality of the reasoning trace, which is present in the response generated from these LRMs. So as you can see in this figure, toward the very leftmost part, they have benchmark the LRM using Math 500 dataset. Here the graph says the pass K versus inference compute budget token. So like thinking, the pass K performance on the thinking model is comparable to the non-thinking model. As you can see here, the red line indicates the Claude 3.7 Sonnet with non-thinking version, and the blue line indicates 3.7 Sonnet with the with the thinking mode. So here you can see like it is comparable for both the LRMs to give the same accuracy or same results. For both the LRMs here, they use Claude 3.7 along with DeepSeek R1 and DeepSeek V3. But in this rightmost part here, they use AIME's 24 and AIME's 25 dataset, and you can see there is certain wide like gap between these two counterparts. So the reason they said about this gap is like AIME 25 could be like because the reduced data contamination in the newer benchmark, which means this the questions in this data set might not be present in the training data set. That's why here there is certain wide gap between the counterparts. So now to the research setup which Apple's use in this paper. For like analyzing the LRM's reasoning capabilities, Apple uses a control puzzle environment. In this paper, they use four controllable puzzle environment. For the sake of this presentation, I will like go through one puzzle called Tower of Honor. They use Claude 3.7 thinking, non-thinking, and DeepSeek R1 V3, R1 and V3, which is thinking and non-thinking mode, with a maximum budget of 64K tokens. And for each puzzles, they generate around 25 samples and report their average performance across all the models. So I will first of all read through this to the what to say the puzzle environment or the instruction like how to play this Tower of Honor game. So basically, Tower of Honor is a puzzle featuring of three pegs. So pegs means the rods you can see in this figure, and this basically number of discs we can increase based on the complexity of the problem. Also, the goal is to transfer all the disks from first peg to the third peg. Then and each valued move include moving only one disk at a time. So taking only the top disks from the peg and never placing a larger disk on the top of the smaller one. These are the rules. And there is specific algorithm to solve this problem, and the minimum number of moves required to shift all the disks from the first peg to the third peg can be calculated using 2 power n minus 1. Here n indicates the number of disks. So yeah, I will just go through one example like how to play this game. This is one of the website which I found. So let's say I have three disks. So the minimum moves will be 2 power 3 minus 1, which is 7. So first of all, I will take this disk in the third peg, this one in here, and then this will be here. And then these are currently I have 3 moves. I made 3 moves. Now this will be the fourth move. This will be the fifth move. This will be the sixth, and this will be the seventh. In this way, I have like played this game. So yeah, uh, this is the basically puzzle they use. They pass through the LRMs in order to analyze the reasoning capability of the uh, models. So yeah, the major
Ajit, sorry to interrupt. So, I'm curious to understand over here, would
Hmm?
problems like these Tower of Hanoi, are they good representation of reasoning problems to begin with? Um, I mean, of course, they are reasoning problems in one sense,
Yes.
but would generally would it be generally a good idea to specify the hardness of the problem with respect to time complexity? So Tower of Hanoi, as you said, is an exponential problem. Uh,
Yeah.
there still can be some problems that are polynomial in nature, but may still require more reasoning than possibly Tower of Hanoi style of problems.
Yes. There are. I guess they use three puzzles in. So I just use the first one, Tower of Honor, but the other are their complexity is what is I guess their complexity is not exponential, but it is like quadratic or something like that. I don't remember right now.
So,
Uh,
do the authors of the paper, I mean, talk about how they uh, define the hardness of the problem with
yeah, I
respect to
mean,
the.
they defined it by the number of disks. If like if the number of disks are increasing, so the number of moves will increase and the complexity will increase. So they define the complexity in this way, like
I mean,
number.
I'm not really sure if that is true, because increasing the disk, I mean, in some sense, yes, it does increase
Yeah.
the complexity of the problem in another sense. But I mean, if we look at the optimized solution, which is a recursive code having
Mm.
three recursive calls, it basically remains the same.
Yeah, I
So
mean, actually, the algorithm is quite robust. Like this, it will just output me the array of moves. So, which means here they provide the complexity with increasing number of disks. I don't know. Also don't understand. But I saw one video regarding this paper. He also mentioned that instead of just asking LLM about this, why not just ask LLM to give us the code uh,
exactly,
outputting the solution of this problem?
exactly. So
Yeah.
that may be an interesting counter argument to what the authors of this paper are saying, right? So uh, they have basically, I believe they are basically not using any external tool as such.
No,
So
no. They
uh,
are just using reasoning models.
yes, so I mean, using tools in the reasoning model will, in a sense,
Uh,
further improve the reasoning.
yeah, means I
So
guess their main goal is to analyze the reasoning tokens, like how the reasoning tokens varies with increasing complexity and how the answer came up. Like
yeah,
for simple problems, the answer came up earlier, and for the larger or bigger.
yes, I mean that's correct. But the
Mm.
fundamental counter argument to the authors of this paper can be that is neglecting the tool augmented reasoning, is it a good idea to begin with?
Yeah,
So,
means
so
I
that can be a
thought.
counter argument. I mean, that is one of the counter argument that many people, many researchers have raised on this paper, which I think is a reasonable one.
Mhm. Yeah, but
Anyways,
I feel like they are targeting the benchmarking of coding and mathematical problems, but they want to know how reasoning works. But the coding and mathematical problems, basically, they only focuses on the accuracy of the models,
yeah, but
not how the
both
model reason.
both of them are correlated in some sense. So treating them as completely different, or treating reasoning as non tool augment without augmenting tools, is something that researchers have argued about basically regarding this paper.
Also, the limitation they provided is like they only use the models without like going through the model architecture. So I feel
Yeah. That's another
yeah,
one. That's true.
yeah.
Okay, let's move
Uh,
forward.
just
Thanks.
sorry
Yeah.
to interrupt again, but if we have time, I have another question on this point that Sachin raised. So very interesting, like school of thought. But just one, I'm just curious about that. The basically the difference of reasoning or amount of reasoning used in like solving a puzzle versus designing an algorithm to solve a puzzle. Like let's say if I want to solve a Sudoku,
Hmm.
how different slash difficult it is to come up with an algorithm or a best algorithm, a good algorithm to solve Sudoku. So I think there here lies some difference in reasoning. Uh,
Absolutely.
Yes.
so I think, and I personally I think that if I think about it in this way, I think there is more amount of reasoning used. I think at least intuitively that if I wanted to solve a like 100 cross 100 Sudoku versus coming up an algorithm which just takes a parameter 100 and just solve it. So I think, and that's also how the complexity also increases with the increase in number of disks or number of, let's say, should like grid in the Sudoku, right? And it will not change that much with if we are designing an algorithm because it remains the same. So yeah, just my thoughts about
Means
that.
actually normal LLMs like can give us the algorithm with the Python code and we can just run that to
Yeah,
give us the answer.
yeah. So I think reasoning will help if we just try to solve it rather than solve the problem using a tool. So what do you think about it? Uh,
I guess the main goal here is to just confirm like standard LLM versus reasoning LLM, not the agentic part. So
Hmm.
uh,
Hmm.
its main thought of the paper is like what is the difference of adding reasoning in the normal LLMs?
Yeah, yeah, I
Is there
agree.
any major difference occurring or just nothing? Yeah.
Uh, and
So
yeah. Anyways, go ahead. Yes, I'll come back.
yes.
Yeah, we can maybe brainstorm it further someday. But yeah,
Yes.
interesting like a chain of thought here. So yeah, we can move on. Yeah.
Huh. So some of the major findings as like here in the figure in the right hand side, basically what they divide the problem's complexity into three parts. First one, the yellow region indicate the simpler parts, which means less number of disks. Then medium complexity and high complexity. So what this saw is like for simpler problems, standard LLMs demonstrate uh, greater efficiency compared to the thinking models, which means here you can see like Claude 3.7 Sonnet outperforms, or we can say like give similar performance compared with the thinking model. And in the similar here, DeepSeek model also does the same. But the major difference or major what we say major outcome they saw is like for moderate complexity problems, thinking model have a huge advantage over non-thinking ones. uh, that can be seen from the figure only. Here the accuracy for thinking ones are like huge compared to the non-thinking one. The reason for this is given in the next slide, I will discuss further. But and for the high complexity ones, there is sudden collapse for both the thinking and non-thinking models. So this is the major like outcome of the paper is
Uh, I think this can be attributed to the max tokens at inference time, because for this particular problem, as we know that it is the time complexity is exponential in
Mhm.
the number of disks. So the number of tokens that would be required to solve this problem would increase tremendously with increasing every disk, and that is possibly the reason why we are seeing this sudden dip.
No,
Uh,
but actually they have compared it with the same number of tokens for both thinking and non-thinking. So like, let's say
yeah,
20K tokens for,
uh,
yeah.
I mean that makes sense, but that possibly might be the reason why we are seeing that the accuracy goes basically to zero
Mhm.
at eighth disk for basically both the models, pretty much. I mean,
Mhm.
almost, if you look at it.
Mhm. That can be one.
I mean, token length can be another major factor here rather than just the reasoning
Uh,
aspect.
but I guess they didn't explicitly mention anything about token. But
I
yeah,
mean, let's see
that,
what the authors have to say. This is very interesting.
yeah, I also thought about that. Like token can be one constraint for them, but yeah, can see.
Let's see.
So yeah. Also here, mm, uh, like they, yeah, as Sachin mentioned, like they also compared with the tokens budget, like number of token versus the pass-K. So here also they divide into three regions, like simpler, medium, and complex regions. So what they saw is like in the first region, the complexity is low for the problems, and we observe that the non-thinking ones are comparable with the thinking models, and someone are like even better than the thinking one. But the with regard to the tokens, but for the second regime, it basically utilizes the long chain of thoughts, like what we say, chain of thoughts reasoning of the model to actually get the output of the problem. So for the medium complexity problems, the thinking one outperforms with the non-thinking one, and the same for the complex one, highly complex one. Both of them collapse. So this is one output they have shown in the paper. Um,
Uh,
comes with an
so, Athar, do they give an example of what are some easy, medium, and hard problems? Uh,
easy, medium, hard. Basically, number of depend on the number of disks we are putting or asking the LLM. Like if the disks are like below 5, so that can be come under easy questions. If disks are, I guess 5 to somewhat
yeah,
20.
I mean, do they give any other example other than the Tower of Hanoi problem?
Yeah, they use 4 puzzle environments.
Okay.
Yeah. So one of them is like some river crossing. All of them have the same complexity scheme. Like in the tower one, there is tokens. In the other one, there is some persons. Like from for one side, there is number of persons like to cross the river.
Okay.
I can
Okay.
show you the paper.
Okay,
Uh,
I got it. So basically, they are increasing the complexity by
complexity
increasing the
is
scale.
number or certain number of like
Got
this
it.
something like that. Yeah.
Got it. Interesting. Okay.
Uh, so yes. This is the there is section called collapsing of reasoning model. This basically mention like why the models, why not they only cumulate all the results they have find. So yes, here they have used all the state of the art models like the DeepSeek 1, R1, DeepSeek Qwen 32B, O3 in medium and high configuration, and Claude 3.7. These are represented with different color, but all of them have shown similar kind of result with increasing complexity. That is, accuracy goes on decreasing with increasing complexity.
Mm.
But here the interesting part is like comparing the complexity with the thinking token. For the simpler problem, the thinking token goes on increasing up to certain threshold before the hard problem arrives, and after that it's directly goes on decreasing, which can from this we can say that LRMs are kind of giving off their thinking for higher problems, higher complexity problems. But they didn't explicitly mention the like technical reason behind this. They only mention that like they are just giving up their ability to think for higher problems, and that's why the token length it goes on decreasing.
So
Tokens goes on. Yeah.
yeah, sorry. I think we got the answer of the question that we were discussing. Sachin raised earlier that it could be a bottleneck because of the thinking tokens, but right now from this graph, maybe it's not the case. Is that correct interpretation? Because yeah, Sachin,
Possibly.
because they
Yeah.
are not increasing. Like models are like yeah, giving up. It seems.
This is actually interesting.
I mean, they have explicitly mentioned the line like here fundamental scaling limitation in the thinking capability of current reasoning model.
Hmm. This is interesting actually.
Mm.
Hmm.
Uh,
Maybe the training data or the training of reasoning is was in such a way that the thinking tokens were not that much in some problems. So maybe
uh, may actually the training data doesn't involve this kind of problems like
yeah, that's why. So maybe they have not learned to think or like persevere more to a certain extent. Maybe.
maybe that way.
Sachin, do you have any inputs or thoughts about this? If
Actually,
you do,
I had one question regarding this.
yeah.
I mean, yes, it makes sense. But at the same time, um, I I'm just wondering whether the definition of increasing complexity, with which in this case is increasing the number of disks, is uh, is the fundamentally right approach. So what I'm thinking is, uh, like generating a solution that solves this problem
Hmm?
is possibly easier than generating the solution for, let's say, a randomized algorithm that uh, gives me edit matches with a much lower time complexity, uh, uh, more I mean, with a probability greater than a certain threshold. So while the other problem is less dependent on the scale size as such, as a human, I believe that the second problem is probably more difficult than the first one and would possibly require more thinking. So, the fundamental way in which that they have uh, defined complexity, particularly pertaining to this example, I'm not really sure if that is.
Yeah, I mean, I also thinking about the same, like why they are increasing the disks. If they have the answer for smaller ones, they can just use the same algorithm and extrapolate for the higher complexity.
Anyways, that's probably
That's
why
also,
this paper is contested a lot in the research community, and it's a hot topic of debate amongst researchers in the LLM community. So,
Uh, just one question, Sachin. What were you referring to by the second problem? Uh,
okay. So, just think of it. So we know that the edit distance or the Levenstein distance problem is an n square d square problem, where n is the number of strings and d is the size of each string, right?
hmm.
hmm,
Let's say if I ask you to develop a solution to the problem wherein you try to match strings with that have edit distance less than or equal to e, with a time complexity that is subquadratic, and it gives the correct output with a probability greater than a certain threshold tau.
Okay.
So this problem, while it is independent of n as such,
hmm.
or the scale as such, is a much harder problem. And I believe that any reasoning model would make a much better attempt at writing a code for this rather than a non-reasoning LLM. So,
Okay.
so whether uh, thinking of, so their claim that thinking is basically an illusion,
Yeah.
uh, uh, that claim itself to me has a question mark over here. And another thing is that their evaluation also does not really makes a lot of sense. The reason being that they are using static evaluation, right? They're just looking at the final output, figuring out if that is correct or not, and based on that, they are defining the pass at the rate k metric.
Yeah.
In
It's
order
that.
to truly evaluate thinking, so let's say you are an interviewer, you're
Mhm.
taking interview of a person for any particular role. In many cases, I mean, it will happen more often than not that instead of actually looking at the final answer of the candidate, you'll be more interested in understanding how the candidate is thinking to solve that particular problem. And that is what true measure of thinking really is.
Yeah. So I
So,
also thought the same, like while reading the paper, they are just pointing out like why you are using the reasoning model if the standard one are good. They
and
just want to prove that thinking are not like, I mean, it doesn't make any sense right now.
I mean, in some aspects, uh, if you look at it, the claim has some merits. But I mean, after all, I mean, if you look at LLMs in a very fundamental way, they are
Hmm.
basically just pattern matching algorithms, right?
Right.
The way thinking is truly happening is that um, uh, 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 um, it's basically in the way these LLMs are trained. So at every particular token, they generate multiple possible opportunities, and they train the LLM to pick the most probable opportunity to
Hmm.
reach to the final answer, instead of just deterministically saying that, okay, uh, take this token take this token after this and so on, based on a, I mean, just a simple linear path. So
Yeah.
that training process itself in a sense it would instill some thinking ability, but whether it is real, whether it is analogous to true human thinking or not, I mean, we just don't know as yet.
Yes, I also thought. Means here also they mention like for simpler problem they arrived the solution in earlier thoughts, but for mediocre complex problem they first iterate through various incorrect path and then arrived at this correct answer. I also thought that why they are not just thinking in the straight correct path for the mediocre problems also.
Anyways, let's take it forward.
Yeah. So another finding is like they also go through the reasoning trace of the response they got through this problem. So where they examine the patterns and characteristic of the intermediate solution, that is the thinking trace of the response. They find the correctness related to the sequential position. Like they try to find where the more thinking trace gives the correct answer according to the sequence token of the thinking trace. And they find the output as you can see in this figure. Like for the simpler problem, um, they arrived at the correct answer earlier, and after that they just like try to give incorrect path, goes in the incorrect path. But for the mediocre complex problem, first they try to like goes in the incorrect path, and this trial of error kind of thing they just arrived at the correct path, which means like for simpler problem reasoning model often find the correct solution earlier in their thinking, but they continue exploring the incorrect solution. However, when the problem become moderate more complex, the trends kind of reverse. Like model first explore the incorrect solutions, and later it they arrive at the correct ones. But for the higher complex scenario, like after n equal to 10 or 15, like number of bits are equal to 10 or 15, it they actually collapses, that they didn't provide the correct answers for them in the reasoning part.
Uh,
Uh,
just one point, and like let me know if it's correct or not. But is it just probability that, because if there's just one or like So, but let's say there's one correct answer. So if, as we go increasing the n, then the sample space of incorrect paths increases. And
In the last slide, you can see like they just like gave up the thinking tokens. So which means they, I guess they just arrive at the incorrect answer for the longer, complex, higher complex questions, and they just gave up the thinking part. And
yeah,
just
but I'm talking about also the easy and medium ones. Is it just like because there is one correct path and 100 incorrect path, let's say in n equal to 2, and
Mhm.
in n equal to 5, there's one correct and 10,000 incorrect. So probably like
Yeah, means I
statistically.
also had the same question, like why they are just first for the medium questions, they're just first exploring the incorrect one and then arrive at the correct one, but not the same for simpler one. For the simpler one, they get the correct answer earlier, and after that, they explore the incorrect one.
Hmm. Yeah.
That was the observation they have.
Okay. Yeah. Yeah. Something to think about. Yeah.
Uh, yeah, I also had the same question, but uh, and this one is the important thing that I spot. As I also thought like why they didn't provide a algorithm in the prompt and just ask him to follow the prompt, follow the algorithm in the prompt, and just arrive at the correct answer. But even though they provide the algorithm in the prompt, the accuracy versus the complexity graph is the same as that of before. Like here, the dashed line indicate that they have put the algorithm in the prompt, and the straight line indicate that the default prompt with no algorithm provided. But for both this, mm, like the complexity versus accuracy is still the same, like goes on decreasing and then collapses to zero for both the DeepSeek R1 and Plot 7.3.7. So yeah, means this is, I guess, something we can discuss. Uh, so this is the limitation of the reasoning model, which I find.
Interesting.
Means they also give the algorithm even though the model still collapse, like it's not following the instructions that people provided, and it just hallucinating. It's a trial and error stuff.
Hmm.
Yeah, means,
Need to read this more properly.
yeah. This is the example of the prompt they have used. Just put the tower of an prompt. So like this was the
Hmm.
system prompt. Mm,
Okay.
this is the example, and the output is like the number of is the array of moves. Here this only gives the instruction like how to give the output, and yeah, means they just pass the n as a parameter, like n will be the complexity, and yeah, they repeat the experiment for different n.
Interesting.
And that's all about the paper. So main limitations about the paper is like uh, the puzzle environment reflects only the narrow range of real world reasoning tasks. As Sachin mentioned, like there can be various scenario, various examples that we can run to see the reasoning. Also, like they didn't have access to the internal behavior, like internal structure of the model. They're just using the APIs to call the model, and yeah, they are- they didn't dig into the model structure, like how it behaves during reasoning or non-reasoning. Uh, and for such problems, they have proper simulation validator, but there can be some real world problem there where we don't have validation for it.
Uh, do they explicitly talk about token limits and possibly early stopping as a limitation? I mean, do they explicitly mention this in the paper?
Token limit may, which means like they mention that
Yeah.
during
So I mean,
experiment.
failing to reach uh, the answer because the maximum number of inference tokens are over. And of course, this is a known fact that for many of these reasoning models, the performance drops very quickly as the context window increases, particularly beyond 64,000 tokens. And I mean, many of these problems, like Tower of Hanoi for large number of disks, will require a lot more than that. So that
Mm,
itself can be another limitation. Then one tool
they
augment.
didn't mention anything about like token limit exceeding or such that they just provide like they explicitly mention like LLMs kind of give up after certain threshold of complexity, like for higher complexity.
Then basically neglecting tool augmentation in reasoning, I think, is also a very major limitation of this paper. I mean, their claim is very strong, but it lacks that fundamental analysis that had to be done to reach this conclusion. But
Ah,
because that is how we humans tend to think as well.
yes.
Uh, uh, yeah, this is interesting. Parth, do you have anything to add, guys? Others on the
Um,
call?
yeah, like if anyone, I would love to hear new opinions. But yeah, I think my opinion about that point was that like tokens limit was not even like hit as per the graph Athar showed a few
Yeah,
minutes back. So like
it's like
even
they.
yeah, like 20K, beyond 20K, it did not even reach.
Hmm.
So I mean,
So that is not a problem. Like
that might not be.
I mentioned, the token limit is around 64K, but
Yeah,
that.
so they did not even use their full capacity or reasoning, maybe.
Hmm.
But yeah, I mean, interesting. Yeah, if anyone else has any opinions about anything or this, yeah, would be great.
Uh, I guess no one is there. So can we conclude now?
Yeah, so
Uh,
I think maybe we can wrap it.
Anything to like Aman want to end? Or-
First of all, thanks for this session, Athar. It was kind of you to have gone through the paper and help us understand it in I mean, real quick. So really,
Yeah,
thank you for that,
Thank you, Athar. Very nice discussion.
thank you.
you guys. Good night, everyone.
Good night.
Good night, everyone.
Hello, Aman. Hello. Mm. Hello, Aman.